Let's talk a little bit about fiber optic cabling. Looking over the worksheets, it looks like fiber optic was a little confusing as compared to our copper Ethernet cables. And rightfully so, we don't see fiber optic very much at sort of the home level or even the small network level. So fiber optic cables use a very, very thin piece of glass inside, and then they have a sheath around them. Not unlike a copper Ethernet cable, which has thin copper wires with a sheath around that. What you see here are three different connectors that are common. So you have ST, SC, and LC. And LC is much more common these days. And the reason we've moved towards LC, notice that there are two parts of the connector on the end of it. So let's talk about duplexing. It doesn't come up till next chapter, but it's important before we continue with fiber optic cables. So we have simplex. There we go. Simplex, which means data only flows in one direction, only that way. And then we have duplex. And with duplex, data flows both directions. But duplex can be divided into half duplex and full duplex. And we almost always refer to one or the other of these rather than just duplex on its own. So half duplex, while data can go both ways, it can only go one direction at a time. So if we're sending data, we cannot also be receiving data. Whereas full duplex, we can do both at the same time. So where do we find these sorts of things? Well, simplex, think of it like a radio broadcast. So you have a radio tower. So there's our radio tower. And it broadcasts, let's say, an FM signal. So if you have a radio station that you're tuning into in your car, the tower broadcasts and you, in your car, receive it. And it only goes that direction. You can't take your car radio and broadcast back to the tower. It doesn't work that way. It's one direction only. So that's simplex communication. Now with duplex, most, in fact, pretty much all networking is duplex, but some of it's half and some of it is full. So if we're doing Ethernet on a hub, we're usually talking about half duplex. So imagine that you have a one-lane road or a one-lane bridge. So you've got a highway like so, and then there's a bridge, and the road narrows like this. And only one car can pass. Well, that means if you're going this way in your car and you see headlights up ahead, you have to pull off and wait for this car to pass before you can then go. So cars can travel both directions, but only one can get through this narrow bridge at a time. That's half duplex. All wireless is half duplex right now. And I think scientists are working on that, but currently all wireless, Wi-Fi, Bluetooth, you name it, is half duplex. It's just that we've made it so fast, you don't really notice that it's half duplex. Now, full duplex is what we get when we're using modern Ethernet using copper cabling. So here you've got your switch, you do your star topology, and what you have here, let's put in three clients, A, B, and C. A can send data through the switch down to C, and at the same time, B can send data to A. So A is both sending and receiving data, and it's doing so simultaneously. How does it do it simultaneously? Well, if you remember, an Ethernet cable has 8 wires. 1, 2, 3, 4, 5, 6, 7, 8. Some of these wires are set to transmit. That's all they do. They just send. Some of these wires are set only to receive, and that's all they do. So what we have to do is match up the sending wires to the receiving wires on the other side, and vice versa. And now we have full duplex. This wire only carries data one way, this wire only carries data another way. And when you put them all together, you can send and receive simultaneously. Now, if we come back to our fiber optic connections, this connector and this connector, the ST and the SC, are half duplex. That is, they only send or receive. They can't do both at the same time. And hence why we're now using something like this LC connector more commonly. One of these wires, or one of these, fibers is for sending, and the other one is for receiving. So they each have a dedicated direction, a dedicated pathway. Do notice fiber optic cables can go much further. So this is 2,000 meters or more. That's 2 kilometers. We also have multi-mode and single mode. So multi-mode, on the sort of appearance of it, seems to be much worse than single mode. It's slower and it can't go as far, but it's also way cheaper to produce, and that's the key. 2 kilometers is enough to connect buildings on a campus, almost any campus, in fact, going from one to the next. Whereas you would use single mode if you're going down a highway, if you're going to connect 2 cities that are miles and miles and miles apart, that's when you would use single mode. Multi-mode uses what's essentially an LED light to send the signal. That's what generates the actual photons that travel down the fiber. Whereas with single mode, it's a laser. Again, more expensive to produce equipment that uses that. So there's your 2 types. So several different connectors, multi-mode and single mode cables. They carry light or photons, and that's fiber optic as compared a little bit to copper Ethernet.